Hey everyone! So far in the series, we have containerized front-end apps like React and Vue. But now it's time to move to the backend. In this video, we will see how we can containerize our Flask application using Podman, and by the end, you will know how you can run a Flask application inside the containers. In this video, we will create a simple Flask app, write a Dockerfile, build the images using Podman, run those images inside our container, and then expose our API. So let's get started in containerizing our very first Flask application. First, let me open Visual Studio Code. I'll click on Open. I'll select the directory that is a mastering Docker. Open. Now, I'll create a new folder in my root as Flask. And inside that, I'll be creating a file called as app.py. Again, Flask is a framework of Python for developing a full stack applications. Now, inside this app.py, I'll be defining my logic. First, let me import some functions, that is from Flask, import Flask, then render template, then I'll be using JSONify. Then I'll define a function named createApp, and inside that I'll define a variable called as app, which is used to Flask, which is used to create the object. Then once I create an object of Flask, then I'll be using the same object and I'll be invoking a method called as route. Now, what is this route? Route is a function that will match the pattern of your URL and call the respective or corresponding functions associated with that pattern. So for route slash, I'll define a function called as index, and in that I will return render template, and I'll mention the file as index.html. Now, what is this? Now, render is a function that will go and look after a folder called as templates in our application directory, and inside that it will search index.html. So based on the renders execution, I have created the folders and the file. Now let me add the boilerplate, and in that I'll mention as Flask app, and in the body I mention as containerize your first Flask app. Yes. So this is done. And then what I'll be doing is I'll be returning the app. Then I'll define the main function. If namespace is equal to main, then I'll call this createApp, and using that object, I'll run it with debug mode equal to true. Now, inside my Flask folder, I'll create a Docker file. And along with the Docker file, I'll create another file called as requirements.txt. So requirements.txt is a file where we'll mention what are the different packages and libraries my application is dependent on. First, my application is dependent on Flask. So here it is F capital, and the version is 3.0.3. Then I'll be using something called as GUICon. GUICon. So I'll be using the latest 2020 22.0.0. Now, why do we need this GUICon? Why do we need this GUICon? GUICon is an web server gateway interface where it will act as an interface for my web server gateway. That means all the requests that will be raised to my application will be processed by this GUICon's gateway interface. Then I'll go back to my Dockerfile, and here I'll define the runtime environment that my application needs. We have seen what is the structure of Dockerfile in our previous videos, so we'll follow the same pattern. First, we'll define what is the runtime environment my application needs. So I'll be using Python of version 3.11, and I'll use this slim images. And then I'll declare the work directory as /app, and I will copy requirements.txt inside my app. Then once I copy my requirements.txt, I'll use the run command pip install -r requirements.txt. Now this flag means I'm using it as read only, and this is the name of the file. But inside my container, I'll be passing one more flags called as no cache directories, meaning I don't want to cache the installed libraries. So whenever I run this command, my function, my CLI won't be using the cached downloads of these libraries. It will uncache it and will install back. Once this is done, I will copy the source code from my directory inside the container, and then I'll expose my container port as 5000, and I'll define the command that is used to execute my container. So here I'll be using GUICon, and I'll be using a bind flag that is -b and -b bind, and here I'll specify the port that is 0.0.0.0:5000, and I'll mention the workers as 2. Then I'll mention the timeout as 120 seconds, as 120, and then I'll pass a flag called as keep alive for 2 seconds. And then I will call my startup function that is app create app. So this is all we are supposed to do. And then once we define the Docker file, we'll go and we'll create a Docker ignore. Now, inside this Docker ignore, we'll mention all our files and directories that we need to skip whenever we are copying into my Docker container. So first is pycache, and then PIO, PYD, DB, logs, envs, vnvs. Then we'll go for dstore, idr, then .vs4, then we'll ignore the Docker file, then Docker ignore the README file. So these are the different files which we'll be ignoring when we are copying the contents from our source code into my containers. Then let me open the terminal. So first, let's test whether we are able to run our Flask application. So I'll just move into my Flask directory and I'll be using Podman build to build the image. So I will be using -t to tag my image as Flask app and I'll specify where my Docker file is. So Docker file is present in my root directory, that is directly from my Flask. So I'll mention it as dot and hit enter. So let's wait for our image to build. Here you can see that my Docker image is built successfully. So the Python 3.11 is pulled. Then I have used the cache directories. Then I have tagged it as Flask app at latest. Now I'll just clear the terminal and now I'll be using the image which I built just now to run inside my container. So I'll use Podman run. I'll specify the port as 5000 at 5000 and I'll specify the name of my image. I hit enter. So let's wait for a container to spin up. So sometimes it might take time. Here you go. Now here we can see that our Flask application is running successfully. Now I'll move into my browser and here I'll search localhost 5000 and here you can see my containers, the content of my container. Whenever I go for slash, it will call a function called as index, which will return a file called as index.html. Now I'll come to my index.html and here I'll do some modification. That is, this is a test line. Now, if I come to my browser, if I try to refresh, I can't see it. That is why whenever we do some modifications, we need to rebuild that image. So I'll just close this terminal. I'll just clear it. And now I'll be using the same command to rebuild my image. I'll just hit enter and it will rebuild my image with the modifications what I've done to my application. So let's wait until it builds. Here you go. The build is successful. Here we can see the build is done. Now I will be using another command, that is podman run -d -p and specify the port and the image name. So what does this do? -d is nothing but a detached flag, meaning all the logs won't be shown inside my terminal. Meaning now when I used to run podman run with port number and image name, all the logs of the container was visible in the terminal. If I don't want to show the logs inside my terminal, then I'll be using a flag called as -d, which is a detach flag, which will detach the terminal when the container is spun up. So I'll just hit enter. Here we can see what are the changes it will do. Let's wait for a container to spin up. This command will just return me the container ID, not the logs. So let's wait till it returns the container ID. Till then, we'll do one thing. We'll open Podman desktop. Yes, let's wait. Yes, here you can see a container was spinned up. And let's wait for it to restart. Yes, here you go. We can see the container ID. If I come to Podman desktop, here I can see my container running. If I click on that container, I can see the logs. And the logs are yet to be listed. Now, if I come and refresh in my browser, here you can see the new line which I added in my image is visible. So if I come to my container, okay, because of my system issue, the logs are not visible, else it would have been visible. So please check out, the logs will be visible inside the logs section. So my system is a bit lagging. We'll figure it out. Now we have done the base step. Now how can I stop the container using Podman? So I'll run Podman stop and I'll copy the ID which I received when I run the previous command and I'll just paste it and I'll hit enter. So this command will stop the running container. So let's wait for the container to stop. Come here, let me go back. Oh yeah, you can see the logs here. Okay, it has stopped the container. Let's see whether it is reflected here. Yes, it is reflected. Now, what I'll do is I'll just modify the app file. Here I'll add multiple routes. App at route. I'll mention the API endpoint, that is API/hello. I'll define a function called as API hello, where I'll be returning a JSON response using JSONify, and I'll pass it as an object with variables message. See it as hello guys, and here I'll pass the status as success. Along with that, I'll define another app endpoint at route. Here I'll mention it as /health, and here instead of this I'll define in single line. Now, since I made this modification, I need to rebuild my image. So let's rebuild my image. Yes, the image is rebuilt successfully. Now I'll clear the terminal and I'll run my Flask app, the image which we built just now. So I have got the container ID. Now, without using Podman desktop, how I can see the running containers? So I'll be using a command called as Podman ps. It will show all the running containers. So here I can see the container ID, the name of image the container is using, what is the command I use to run the containers, what is the status, at what time it was created, what port it is accessing, and what is the name of the container. Now if I run Podman ps-a, it will show all the running and non-running containers inside my Podman desktop. So this is an CLI version of Podman UI. So let me click on this. Yes, here you can see the logs. Now if I come here, if I refresh, not much changes. But if I go to this route /API/hello, so it is returning hello guys, status as success. Then if I go for health, okay, page was not found. What was it? Okay, API/health. It is API/health. So API is healthy. And if I come back to my containers, so there are no logs because we didn't use loggers to log our application. Now, this is how you can containerize a Flask application using Podman. In the next video, we will see how we can containerize APIs that are built using Node.js and Express in the coming video. So till then, if these videos have helped you a lot in understanding what is this containers, please do like and subscribe the channel for more upcoming and interesting concepts of Docker, which you will never find in other playlists. So till then, stay tuned and keep learning. Thank you.